All right, so what we want to do now is we want to combine our logical operators with conditional statements. And what this allows us to do is to engage in a greater complexity whenever we're doing comparisons. We can also be more specific about the conditions we want to run. So in this example here, we're going to start with the AND logical operator. Now, if we look here at the variables and the values we've declared them with, we have x equals 6, y equals 3, and z equals 10. So now we're going to look at these conditional statements using the AND logical operator. So the first thing we ask is x less than 10? The answer to that is true. Is y greater than 0? The answer to that is true. Is z not equal to 10? The answer to that is false. So we go in this order. We say we have true, true, false. So let's look at what happens when we have our logical operators. We have true and true. Both values are true. Therefore, the combination of these two is true. Now we have true and false. Both are not equal to true. We have one false value in there. And for AND operators, all of the conditions must be true. So we end up with a logical value, a combined logical value of false. Next, we move on to the OR logical operator. We're going to do something similar. So here we have, is x less than 5? That is false. Is y greater than 0? That is true. Is z equal to 10? That is true. So here we have false or true. Because at least one of the values is true, that comes to a combination of true. So now we have this combined answer of true or true. Both of them are true, and that's at least one of them being considered true. Therefore, we have a logical value of true. Simply put, whenever we're working with AND, all of these conditions must be met for this to be considered true. Down here, any of these conditions can be met, and this whole statement is considered true. So when working with logical operators with your conditional statements, that's what you need to keep in mind. Is this string of questions right here, do they all come out true when we're working with our AND logical operator? If we're working with our OR logical operator, are any of the conditions true? Now, when we're using the NOT logical operator combined with our conditional statements, there's something we need to keep in mind is that when we're using the logical NOT operator with a conditional statement, it will negate an expression which is normally true and it'll return a value that is false. Or it'll take an expression that is normally false and return a value that is true. This is not the same as the math operator not equal to. A lot of times people get those confused. So let's look at like the little example that we have here. Here we have a logic value, 10 equals 10. That is true. Logical not, whenever we put the not operator in front of this, it comes back to false. Okay, so here we have logic value, which equals true, and our logical not, which returns a false. So if I go here to the logical not, I can also say that that equals the logical operator not of our logic value. So we have a logic value equals true. When it's introduced to the not operator, it returns a value of false. We can also cancel that logic basically with a double negative or a double not. So I've taken the logical not value, which equals false. I've placed it here alongside a not logical operator. So we have false, not false, which equals true. So that's the way to think of it. We have a value, logical value, which equals true. So we have not true, which equals false. Again, we have a value here, logic value that equals true. Then we put a not in front of it. So we say not true, which equals false. Then here we have a value that equals false. We put a not in front of it and we end up not false, which equals true. Okay, to review, we have our various logical operators, and once again, all of the expressions must equal true for the AND logical operator to come out true, or any of the expressions could equal true for the OR logical operator to come out true. The equivalent just says, are they both false or are they both true? And that one will come out true. Exclusive, if the expressions come out to different values. One is true and one is false. Implied is always considered true unless expression A is true and expression B is false. This one's very specific. Finally, we have our not logical operator, and what that does is it takes a value and it converts all of those values into binary, changes all the ones to zeros and all the zeros to ones. And the thing to remember is that logical operators are utilized like arithmetic operators only for binary numbers. And what this allows us to do is to combine this with conditional statements or if-then statements to allow for a greater complexity in comparisons and more specificity in conditions. Now, something to keep in mind is that the order of operation does play a significant role in the use of logical operators. Just like when we're doing arithmetic, we have to keep in mind how our operations are carried out. So if we look at the example here, we see x equals true, y equals false, and z equals false. Now, the highlighted circle portion, what you need to notice is that in this expression right here, x or y and z, the first thing that happens is y and z, that is evaluated first. Then the combination, the result of that, that is combined with an or statement in x. So we have y and z equals false, that's evaluated first. Then x, which is true, true or false. That comes out to be true because we have at least one condition that is true. Now, we can change that by putting parentheses and forcing this expression to be evaluated first. So by putting parentheses, we force the x or y expression to be evaluated first. The result of that is then combined through an AND operator with z. So if you notice, see how these look very similar, but because we put parentheses in there, we get two different answers. So our logical operators are not evaluated left to right. They do have an order of operations. In this case, AND operators are evaluated before OR operators.